Greetings, and welcome to the tutorial. Today I will be covering the ins and outs of Polkadot bounties, child bounties, multisigs, proxies, and permissions. You will learn how these things work on Polkadot, how to configure them, how to interact with them, and the implied consequences of on-chain permissions. This tutorial is not for the average dot user. It's intended for ecosystem professionals in Polkadot, especially ones who are responsible for managing bounties. So I already assume that you have a basic understanding of how to sign transactions and utilize apps like Subscan, Polkadot JS, Multisigs, and so on. All resources mentioned in this tutorial can be found in the video's description. With that said, let's get started. Before we dive into the technicalities of interacting with bounties, I'd like to start by explaining what exactly a Polkadot bounty is. The Polkadot treasury may be spent in a variety of ways, the most common being a direct spend, where a proponent receives funds directly from the treasury, which requires each spend to be approved by a majority of voting DOT token holders. Another way is with a bounty, where voters simply approve a bounty under a general category, and then propose a curator to that bounty. It is always expected that a bounty curator be a multisig composed of many diverse individuals to ensure responsible fund management. Also, a fee is often set aside for the curator to compensate them for their efforts. This fee comes out of the bounty's total budget. Essentially, a bounty on Polkadot is a program to curate funds toward a specific goal without needing to involve voters for each spend under the program. This is achieved through something called child bounties. Bounties on Polkadot are almost always split up into multiple different spends, called child bounties. Please note, a Polkadot bounty is referred to as the parent bounty because it can create many child bounties from itself. We will use this term moving forward. To get a basic idea of what a child bounty is, just remember this very important comparison. A parent bounty is to the treasury, as a child bounty is to a parent bounty. For example, if a parent bounty category is for advertising in the amount of 10,000 DOT, a child bounty category could be something like advertising campaign at the LAX airport for 1,000 DOT. So child bounties allow a parent bounty to split up its budget into multiple spends toward subcategories. Before we go into the specifics of child bounties, I would like to mention that unlike the establishment of a parent bounty, which requires DOT token holders, child bounties can be established solely by the parent bounty. We'll dive into these relationships and permissions in more detail later. When a child bounty is added by the parent bounty, the amount of DOT for the child bounty comes out of the total budget of the parent bounty. Keep in mind that there are two aspects to the total budget of the parent bounty, the payout aspect and the curator fee aspect. Child bounties also have these two aspects, since they too require a curator, which is proposed by the parent bounty. Let's look at our example to see how the accounting of a parent bounty plays out. Let's say Team A is in control of the advertising parent bounty, and their fee is 700 DOT. Team A wants to hire Bob to make sure that LAX airport delivers on their advertising campaign, and Bob's fee is 70 DOT. Bob is proposed as the child bounty curator, thus giving him complete autonomy of the 1,000 DOT set aside for the LAX campaign. Based on his assessment, he believes that LAX has sufficiently delivered on the campaign, so Bob awards them the child bounty. Let's look at the parent bounty's budget after this child bounty has been awarded. As you can see, the parent bounty now has 8,370 DOT left in its payout aspect and 630 DOT left in its fee aspect. In other words, child bounty payouts come out of the parent bounty payout, and child bounty fees come out of the parent bounty fee. Let's examine each step of the establishment of a parent bounty and a child bounty to understand how permissions trickle down from the highest authorities to the lowest. First, a parent bounty must be proposed by someone before DOT voters can approve it. Anyone has the ability to propose a parent bounty, which is done by indicating the amount of the parent bounty and a description of its category in a proposed bounty transaction. This action currently requires a deposit of 1 dot, which remains reserved until the bounty is closed. Once a bounty has been proposed, no one can close it except for dot voters. This is the beginning of the trickle-down of permissions from the highest authority, dot voters. At this point, anyone can submit a referendum to approve the bounty. This tutorial will not cover submitting referenda since it is out of scope, but there are plenty of resources available on how to submit a referendum on Polkadot. Anyway, once a referendum is submitted to approve the parent bounty, dot voters decide whether it should be approved on the basis of its category. If the referendum passes, Polkadot will generate a keyless system account and fund that account with a designated amount of dot from the treasury. However, this account remains inaccessible except through a referendum to close the bounty, thus returning the funds to the treasury. At this point, another referendum can be submitted by anyone to propose a curator to the parent bounty along with that curator's fee. Again, dot voters decide whether the curator is trustworthy and capable of curating the funds and if the fee is acceptable. If the referendum passes, the curator will be officially proposed, endowing the curator with permission over the parent bounty. However, before the curator can manage the parent bounty, they must first accept the curator role by placing a deposit, which is currently equal to half the curator fee, with a minimum of 10 dot and a maximum of 200 dot. For example, if the curator fee is 100 dot, then the curator would need to place a deposit of 50 dot to accept the curator role. If the curator fee is 10 dot, then the curator would need to place a deposit of 10 dot, since 5 dot is below the minimum. If the curator fee is 1,000 dot, then the curator would need to place a deposit of 200 dot, since 500 is above the maximum. This deposit is locked until the bounty is closed or awarded, which can be done only by dot voters or the parent bounty curator. Once the curator has accepted the curator role, they may begin adding child bounties. In similar fashion as before, permission is endowed to the child bounty curator from the parent bounty curator. Therefore, when a child bounty has been added, Polkadot creates another keyless system account and funds that account with the designated amount of dot from the parent bounty system account. This account can be managed by the parent bounty curator, either by proposing a child bounty curator or by closing the child bounty. If a curator has been proposed for a child bounty, the child bounty curator can accept the role by placing a deposit equal to half of the child bounty curator fee, subject to the same minimums and maximums mentioned before. After the child bounty curator accepts the role, they will have permission over the child bounty to award it or close it as they see fit. In conclusion, you can see how permissions trickle down from dot voters to the parent bounty curator to the child bounty curator. Now let's test your knowledge so far. Question. Suppose there are two separate parent bounties, Bounty A and Bounty B. Each has a different curator, Curator A and Curator B. Dot voters have given them both permissions of the respective bounties, which must mean that Curator A can create child bounties for Bounty B, and Curator B could create child bounties for Bounty A. Is this true or false? Answer: false. All because a curator has control of one bounty does not imply that they have control of others. Even though the permissions of each curator come from the same source, those permissions are fundamentally different. Question. Can dot voters create a child bounty after a parent bounty curator has accepted their role and placed their deposit? Answer. Yes. Dot voters are the highest authority in Polkadot and can literally do anything through referenda. All because they endow permission to a curator does not mean they transfer their own permission over a parent bounty. Question. If a parent bounty proposes a curator to a child bounty, and that child bounty curator accepts the role, Can that child bounty curator create another child bounty? Answer: no. Child bounty curators only have control of their respective child bounties. Additionally, a child bounty is the finest division of bounty funds. You cannot divide child bounties into more child bounties. Trick question. Can there be multiple curators on a bounty? Answer: yes and no. It depends on what you mean by curators. If you mean the account that is proposed to be a curator, then the answer is no, because only one account can have the curator role on a bounty. However, if you mean the individuals involved in the account that has a curator role, then the answer is yes, because that one account can be a multisig. Now that you've been warmed up, let's go into interacting with bounties on Polkadot. Before I continue with this tutorial, especially with the demos, I just want to address something that I think will upset some people watching this video, and that's the fact that I'm using Polkadot JS as an application, and I understand that there are people who believe it is a flawed application, that the user interface is complex and not very user-friendly, and that users should be encouraged to use applications that make submitting transactions, especially complicated ones, easier. However, remember, this tutorial is not for the average dot user. It is for professionals, okay? So moving forward, well, let me just show you something, okay? You see this right here? That is the cockpit of a Boeing 737. Does that look easy? Does that look simple to use? No. You have to be professionally trained in order to operate this cockpit. Now keep in mind, these pilots who operate this aircraft, they are very familiar with all of the instruments and what every single switch and dial and button does. Okay? So with proper training, this becomes a very simple and great layout, honestly. Like, Boeing is not stupid. They create airplanes that are safe and good to fly in most cases. Let me show you something else. This is the command module for Apollo 11. Does that look simple? Does that look user-friendly? No. You're going to the moon. Okay? Do you know how many systems are involved in managing a craft like this? Okay, now these are extreme examples whose complexity is a bit greater than I think interacting with Polkadot. So even if you're hung up about how complicated Polkadot is, just imagine how many pilots are out there flying aircraft every single day using their instrumentations. And yeah, they probably have their opinions on the cockpit and which model of aircraft is the best to fly and which one has the best, which one has the worst cockpit. Great, you are entitled to those opinions once you are an expert in that field. So I'm using Polkadot JS because it is our cockpit as professionals. People are trusting us to be able to interact with the blockchain in literally every single way possible. And there's no application that can do that except for Polkadot JS. Yes, it sucks. It's difficult and it's complicated. It's not very intuitive. It will take time to learn. But I promise you, if you dedicate yourself for 2 or 3 weeks just learning how to submit extrinsics and what Polkadot JS is and all of its features, you will be proficient in all interactions that are possible in Polkadot. Okay, with that said, let's move forward with the demos. First, I'm going to show you how to propose a new bounty on Polkadot. It's permissionless, and anyone can do it as long as they place the deposit. You want to make sure that you're connected to Polkadot JS, and make sure that you're connected to the Polkadot relay chain. Okay? Don't select a parachain and don't select any of these other ones. You want Polkadot. Select your RPC endpoint of your preference. I personally like IBP. but any of these will do. These are just the data providers. And make sure that you click switch instead of fork locally. If you fork it locally, it'll create an instance of Polkadot that's not real. Once you're connected to Polkadot, you want to go to Developer Extrinsics. And I know there is a Bounties UI on Polkadot JS, and you can add a bounty like this, but I don't like that because it doesn't give you an intuitive understanding of what's happening. Okay? This extrinsics page will tell you everything you need to know about submitting what you want to submit. You can submit every single transaction that's available on Polkadot here. So you want to go to Bounties. This is the module or the palette that you're working with. And then you want to select the Propose Bounty Extrinsic. And just like I said earlier, to propose a bounty, you just need to indicate the amount of the bounty and a description of its category. So in our example, the ad campaign was 10,000 DOT, and the description was advertising campaign. And it's just that simple. I'm not going to submit this because it'll spam the chain, but I will actually show you in a forked instance of Polkadot. So let's wait till this loads. Okay, it looks like it's loaded now. You can see local fork powered by chopsticks. And that's how we know we're not actually working on Polkadot. And you can see here that the blocks aren't marching. The way chopsticks works is that it will emulate a new block when you submit a transaction. So let's just see what happens when we submit that proposed bounty. We'll go down, propose the bounty in the amount of 10,000 DOT for an advertising campaign. And if we submit this, and you'll see it show up on this bounties page. So let's give it a minute. And there it is. Advertising campaign. It is proposed. The amount is 10,000 DOT. And if you go to the accounts now, you'll see that you have reserved your DOT. Now you might be wondering, why is this 1.2 DOT, not 1 DOT like I mentioned? That's because there is a per byte data deposit on the description of the bounty. That deposit is equal to 0.01 DOT per byte. In other words, it requires 0.01 DOT per character of the description. 1, 2, 3, 18, 19, 20. So it's 20 characters here. So that means that 20 times 0.01 requires a 0.2 DOT deposit for the data storage of the description, in addition to the 1 DOT. So keep that in mind that it's not exactly 1 DOT. And that's how you'd propose a new bounty on Polkadot. The next step would then be to submit a referendum to approve the bounty. The way you do that, and I'm not going to show you exactly how to submit a referendum because I don't want to waste time on that. You go to Bounties, Approve Bounty, and you just indicate the bounty index. Now you just take this encoded call data, put it into a referendum, and if Polkadot approves this, they would then fund that bounty. And we can actually see an example of a bounty that has been funded by Polkadot voters, but not yet assigned a curator right here. This means that a referendum was passed to fund the technical support bounty and is just waiting on a curator. So that is the next step, is once a bounty has been funded through a referendum, a curator needs to be proposed, and I'll cover that next. Now let's say that your bounty was approved and funded by the ecosystem. The next step is to propose a curator. Now we're back at the live version of Polkadot, and just for the sake of demonstration, I'm just going to show you how to configure the extrinsic to propose a curator to a bounty. We'll just assume that we have the parent bounty index of 54 moving forward. So all you have to do is go to the Bounties module and you want to go down to propose curator. And you would reference the bounty ID. And then let's say we want to assign demo 1 as the curator for this bounty. And just like in our example, the fee would be 700 DOT. This is the extrinsic that you'd put inside of a referendum. And if passed, this curator, demo 1, would be proposed as the curator for bounty number 54. Now, before demo 1 can start to manage the bounty, they would need to accept the curator role. So let's just assume that referendum passed and demo 1 has been proposed as the curator with a fee of 700 DOT. Demo 1 would need to come in here and accept the curator role. That is simply done by going to the Bounties module and go to accept curator and indicate the bounty ID. If demo 1 has been proposed as the curator for bounty number 54 and they submit this call, they would become the curator of bounty number 54, provided they have the required deposit. If this were the case, this would still fail. Why? If the fee is 700 DOT, this would require a deposit of 200 DOT because 700 divided by 2 is 350 and the maximum deposit is 200. So if you're going to accept a curator role, make sure that you have the required deposit necessary. And that's how you propose and accept a curator on a parent bounty. Let's assume that a bounty has been funded, that a curator has been proposed, and that curator has accepted the role. And now it's time to add a child bounty. What you would do is go to the Extrinsics tab, and now we're working with a different palette or a different module. We're working with child bounties now. So don't select bounties, you want to select child bounties. You go in here and you want to add a new child bounty. And just like with proposing a parent bounty on Polkadot, adding a child bounty is similar. The only difference is that you have to reference the parent bounty. So if we just use our example of parent bounty number 54, and we indicate the value of the child bounty. In our example, the LAX campaign is for 1,000 DOT, and you just include LAX add campaign as the description. And it's simple as that. If demo 1 is the curator on the parent bounty, this child bounty would be successfully added. Now, I've seen people try to batch this with proposing a child bounty curator. And the issue with that, and I'll just show you here, okay? Let's just look at how many child bounties there have been. So if you go to chain state, you can check to see, you can query data on chain. You go to child bounties and we go to child bounty count. Okay? There have been 1,420 child bounties, and a child bounty is given an index based off of its count. So the last child bounty that was added on Polkadot had an index of 1419 because you have to include 0 as the first index. So that means the next child bounty index would be 1,420. The issue with trying to project what index your child bounty will be given is that you're not guaranteed that index by the time you execute the transaction. Especially in the case that you have a multisig and your team doesn't really execute it that quickly. In the time that it takes to execute that multisig, someone else can add a child bounty and take your child bounty index. So I'm going to show you what some people do, and this is not correct, so don't do this, okay? They try to add a child bounty, okay, 54 in the amount of 1,000 for the LAX add campaign. And in the same batch, they try to propose a curator. So let's say we want to hire Bob to manage the LAX ad campaign, and just assume that Bob's account is this demo 2 account. We would indicate the parent bounty ID of 54, and then we're just guessing that we're going to get the child bounty index of 1420. And then we would indicate Bob's fee of 70 DOT, just like our example. The problem with this is that if some other parent bounty submits an add child bounty interaction, they will get this 1420 index. So then when this tries to execute, Polkadot will look for child bounty 1420 under parent bounty 54, which it will not find it because it will be under a different parent bounty. So this will fail. That is why you must add a child bounty first, so you are given an index that is permanent and referenceable in the future. Now you might be wondering, how do you know which child bounty index you're given after you've added child bounty? And it's very simple. You can either query the data directly on chain. So if you go to child bounties, you can look up child bounties and just indicate the parent bounty number right here. So you have to know that this is the spot where you put the parent bounty ID. Now I happen to know that parent bounty number 50 has an active child bounty, but we don't know what the index is, right? So if I try to guess and like maybe it's 1300, it's like no, there is none. So you can just omit this option and Polkadot will list all active child bounties under bounty number 50. And here we can see that it looks like they have a bounty, child bounty 1316 in the amount of 1,583.17 dot. They have a curator, a beneficiary, and it looks like it's pending an award. So this is, and they have more here. So they have a bunch of child bounties here, and that's how you know what the child bounty index is, because it's right there. Another way you can look it up, which utilizes a centralized source of on-chain data, is to go to Subscan. You can actually filter based on events that happen on-chain. So every time you add a child bounty, Polkadot emits an event called child bounties added. And that's what I've filtered here on Subscan. And you just have to find the extrinsic that you submitted to add the child bounty. And let's just say this one. We want to see, let's assume that we submitted this extrinsic and we want to see the child bounty ID. You can see right here, it assigns it an index right there. And if you go into the extrinsics tab on Polkadot or on Subscan, you can see in the events listed, the child bounty has been added. Now remember, I mentioned that Polkadot creates a system account to manage these funds, and it puts the funds in that account. And that's what it's done here. And you know it's a system account because if you look at the public key, it's padded with a bunch of zeros. So this account here is keyless. It's a system account. It holds the funds of the child bounty until it's awarded or closed. And that's how you would know which child bounty you're working with. So you can go to Subscan, or you can go to the chain state and just look it up, and you'll be able to see. And furthermore, if you want to see the description, you can go to child bounties, child bounty description, and we can do 1316. And there it is. So this is for Amfork Bounty 50 payouts. And they have a GitHub link so we can check it out. Now this query only requires that you put in the child bounty index. So all of this information is available after you've added a child bounty on chain. It is accessible as long as you know how to do it, and now you know. Now let's say you've been proposed as a child bounty curator and you need to accept that role so that you can curate the funds for the child bounty. Just like with accepting a role on a parent bounty curator, it's the same as accepting a role on a child bounty curator. So in our example, Demo 2, where Bob is responsible for the LAX ad campaign. And in order for Bob to accept this role and start curating the funds, he would have to go to Child Bounties, Accept Curator. You would need to reference the parent bounty ID, and then let's just assume we got that index of 1420. So if Demo 2 or Bob here has been proposed as the curator to the Child Bounty 1420, then and submits this transaction, then he will become the curator on that child bounty. Now remember, his fee was 70 dot. Remember that? He is required to place a deposit equal to half that fee, subject to minimums and maximums. So half of 70 is 35, and the minimum deposit is 10 dot, maximum is 200. So Bob would need to place a deposit of 35 dot in order to accept this role if his fee is 70 dot. And if he has that dot, then he would accept this role. That would be reserved until the child bounty is either closed or awarded. Let's assume that for whatever reason a child bounty needs to be closed before it's awarded. This can be because maybe the campaign is canceled or the curator is no longer available. There's a various number of reasons, or even maybe the curator is acting maliciously. The parent bounty actually has the power to close the child bounty before it's awarded. The way it does that is the parent bounty curator would go to child bounties and it would close the child bounty. And if this child bounty is active and the curator has been assigned to it, and this interaction is submitted by the parent bounty curator, this would close the child bounty, and the child bounty curator's deposit, in our example 35 dot, would be returned to the child bounty curator. Now this is an example of if something needs to be canceled or just discontinued and there's no real malicious activity. But let's assume the child bounty curator is acting maliciously. You may punish the child bounty curator with submitting this unassigned curator interaction. If you submit this on an active bounty or an active child bounty, this will unassign Bob as the curator and slash his deposit, meaning that you are punishing Bob for acting maliciously as a child bounty curator. Just be cautious of when you use this, because you want to make sure that you're communicating with the child bounty curators that everything is happening as expected, and if they can even answer for their neglect or certain activities. So please be cautious of when you want to either unassign a curator to slash the child bounty deposit or the child bounty curator's deposit, or if you want to simply close the child bounty to cancel it without slashing the deposit. So those are ways that you can actually get rid of a child bounty without awarding it. Now let's assume that Bob wants to award the child bounty now. So all Bob needs to do, in our example, this is demo 2, is go to child bounties, award child bounty, okay? And let's just say the LAX airport's wallet is demo 3, okay? So Bob would need to indicate the parent bounty ID, the child bounty ID, and the beneficiary. And if Bob is the curator on this child bounty and submits this award child bounty, this will trigger an event, a payout event for this beneficiary. This payout event takes 8 days. Currently, it takes 8 days of a delay for it to become available to the beneficiary. So keep that in mind when awarding a child bounty, is that there is an 8-day delay for now on awarding these child bounties. Now let's say those 8 days have passed and it's time to claim the funds from the bounty, including the fee for the child bounty curator. In order to claim an awarded child bounty that has passed its payout delay, you just need to go to child bounties, claim child bounty. You have to reference the parent bounty ID and the child bounty ID. Now, if the payout delay has passed and everything is good, anyone, any wallet in the entire ecosystem could submit this transaction. It is totally permissionless, and that will trigger a payout to the beneficiary and the child bounty curator. Okay, so anyone can submit this transaction, whether that's the child bounty curator or the beneficiary or some random person who likes to do a little housekeeping for Polkadot. So anyone can submit this, and this would trigger the payout to the beneficiary, and it would pay the fee to the child bounty curator, and then it would release the reserve or the deposit that the child bounty curator placed to accept the role. And that's how you award and claim a child bounty. The word multisig literally means multi-signatory, which implies an account that requires more than just one signer to submit a transaction. Multisig accounts on Polkadot have two aspects: the signatory accounts and the threshold of signatures required to execute a transaction. A multisig account itself is deterministic and has no keys, which means that if you input the same signatories and threshold for a multisig, Polkadot will generate the exact same account every time, which can only be managed by the indicated threshold of signatories. There are three multisig functions that we will be looking at in this tutorial: asMulti, approve asMulti, and cancel asMulti. Let's examine the entire multisig process to understand how these functions work and what they require. For a multisig to execute a transaction, it must first be initiated by one of the signatories. To do this, any signatory may submit either an asMulti transaction or an approve asMulti transaction. Both of these require the submitter to indicate the threshold of the multisig and the list of the other signatories sorted in alphabetical order of their raw public keys. But here's the difference. asMulti requires the user to submit the call data, which is the decodable data that reveals the desired transaction. Approve asMulti only requires a user to submit the call hash, which is the one-way encryption of the call data. A call hash can only be derived by knowing the call data first. While either can be used to initiate a multisig transaction, the best practice is to use asMulti because the desired transaction will be broadcasted on-chain. If a signatory uses approve asMulti to initiate a multisig transaction, they will need to communicate the call data to the other signatories so the transaction hash can be verified to be associated with the desired transaction. The initiator of a multisig is required to place a deposit to store the multisig transaction data on-chain until it is executed, which makes them the sender or owner of the transaction. This deposit is currently equal to 20.088 DOT plus 0.032 DOT times the threshold on the multisig. For example, to initiate a multisig transaction whose threshold is 5 out of 10 signatories, the deposit would be equal to 20.088 plus 0.032 times 5, which equals 20.248 DOT. Only the initiator has to place a deposit, which is freed either upon cancellation or execution. Additionally, only the initiator can cancel the multisig transaction, a privilege afforded by their deposit. Once a multisig transaction has been initiated, the other signatories may then approve the transaction if they believe it's reasonable. While an approval can be done with either asMulti or approve asMulti, the best practice is to use approve asMulti, unless a signatory is the threshold signature. More on that in a bit. The reason for this is because a transaction's call hash is always the same length, whereas a transaction's call data depends on the size of the transaction, which can be quite large sometimes. When approving a multisig transaction that has already been initiated, a signatory is required to indicate the block number and extrinsic index, known as the timepoint, of the initiated call so that Polkadot knows where to look for it. If the timepoint is omitted while submitting an approve asMulti, the signatory will initiate a new multisig transaction. So be sure to include that timepoint if you are approving an already initiated multisig call. Additionally, please note that once a signatory has approved a call, they cannot revoke their approval. Be careful to only approve multisig calls that you believe to be reasonable. If a signatory is the last approval, or the threshold signature, they must submit an asMulti transaction in order to execute it. For clarity, let's use our previous example of a multisig with a threshold of 5 out of 10 signatories. Suppose 4 signatories, including the initiator, have approved a transaction. Any of the remaining 6 signatories may submit an asMulti transaction to execute. The only difference with an executing asMulti transaction versus an initiating asMulti transaction is that the signer must indicate the time point and the call wait. It's not important to know exactly how this wait needs to be configured because there are apps that will do it for you, but there is a way to do it manually that we'll cover in a minute. The reason the wait has to be indicated is because the executing signatory is the one that pays the transaction fee on behalf of the multisig. So what happens if the threshold signatory uses approve asMulti? Do you have a guess based on what you've learned so far? Pause the video to think about it and resume once you have your answer. Okay, here's what will happen. The multisig transaction will not execute. However, since the threshold has been reached, anyone, including the signatories who have already approved the transaction, will be able to execute it by submitting an asMulti transaction. Just think of it this way. If best practices are followed, a multisig transaction should look like an asMulti sandwich with delicious approve asMulti toppings in the middle. Scrumptious. Question. If you try to initiate a multisig transaction using approve asMulti, will it successfully initiate? Answer. Yes. While it's best practice to use asMulti to initiate a multisig transaction, approve asMulti will work fine too. If you go this route, make sure to communicate the call data with the other signatories so they can validate your desired multisig transaction. Question. Can DOT voters submit a transaction on behalf of a multisig? Answer. Yes. Remember, DOT voters can literally do anything through a referendum. However, this would require a root track referendum and would almost certainly fail unless the ecosystem agreed that drastic measures were needed to recover the multisig. Question. If you don't sort the other signatories' wallets in alphabetical order when submitting a multisig approval, will it succeed? Answer. No. In fact, Polkadot has a specific error for this called signatories out of order. Now let me go over exactly how to add a multisig account to the Accounts tab on Polkadot JS. First, you need to connect your signer wallet, whether that's through local storage, which I don't recommend, or through a wallet extension. Make sure that your signer account's imported. Now, for the sake of the demo, I'm controlling all of the signer accounts, but in your case, you'll actually want to add the other signatories in your address book. You just go to Accounts, Address Book, Add Contact, and then you can add everybody's wallet in here. So you paste their address and you can name it whatever their name is. Okay? Now, once you have those accounts imported, either in your contacts or injected into the application, you can go to Add Multisig right here. Now, for this demo, I'm going to select all 4 of these accounts, and I'm going to indicate a threshold of 3. Okay? This multisig, we'll just name it. It doesn't matter what you name it. We'll just call it Demo Multisig. And you hit Create. Now, if you do that correctly, it will generate a multisig account and whose threshold is 3/4. And remember, this is deterministic. So if you input the same signatories and the same threshold, Polkadot will generate this exact same account every single time. Now, please note, if you change the threshold, let's say we add the same 4 accounts and we change it to a threshold of 2, just name it test, it's a different multisig. It's a totally different account because it's a different threshold. These are different inputs. Even though the same is signatories, the threshold is different, so the account is different. Please keep that in mind, okay? So we don't want this 2 out of 4. Forget that. Now, once you've added a multisig on the multisig page, you'll be able to manage it here. And it's just that simple. That's how you add a multisig to the Polkadot JS Accounts tab. Now that we've added the multisig account to Polkadot JS, I would like to go over how to prepare a transaction to initiate on a multisig. Now this is very complicated, so please take note of all of these steps. If you follow them perfectly, you will be okay. So first, you want to figure out what multisig transaction you want to submit. To do that, just build the extrinsic from scratch, okay? To do that, you go to Developer, Extrinsics, and you want to, whatever you want to submit. Let's say we're just submitting a system remark, okay? And we're going to say, hello world. This is our extrinsic. Remember, when initiating a transaction on a multisig, you need the call data right here, okay? So take this and note it somewhere, okay? You can put a new tab, write it down, maybe put it in a notepad, whatever you want, but make sure you save this call data because it will be needed later on. And you find that right here, encoded call data. Don't use the call hash. This is different. But we can also note that as well. So there we go. We got the call hash, call data, and just these two random tabs. Okay, now that you have the call data, let's go into building the multisig extrinsic. Remember, you're initiating a multisig transaction, and for this, we're actually going to use demo 1. We're going to use multisig. Now, anyone on the multisig can initiate a transaction. And remember, when you're initiating a multisig transaction, you want to use asMulti, not approve asMulti, use asMulti, because this publishes the transaction on chain so that people can validate what you're trying to do. You want to indicate the threshold on the multisig, not 2. Remember, we did that, and that created a totally different multisig. We want a threshold of 3. Now, you want to include the other signatories. Remember, there are 4 signatories on this multisig, which means we need to include the other 3 here. Now, you can't just do this in any old order. You have to do it in alphabetical order. And this is where it gets a little bit complicated, okay? Because you can't use the Polkadot. So if we use the Polkadot format, which might be in alphabetical order, but there's no guarantee, you'd go demo 3, demo 2, and then root demo here. And these are in alphabetical order according to the Polkadot format of the wallet. But you need to sort them in alphabetical order based off of their raw key. Okay? In order to find an account's raw key, what you need to do is use this account format transform on Subscan. If you don't want to use this centralized source of account transformation, I'll include a link in the description to a tool called Subkey. This is something you can install on your machine, and then you can do these account transformations totally locally and independently. So what you want to do is first just create a spreadsheet. Okay, just create a spreadsheet and put everyone's account in there. Okay, so we're gonna do. We'll start with root demo. Okay, now that we have these recorded, we can actually derive their raw public keys. So we'll just say name, say Polkadot account, and then we can say raw. Okay, so just copy this, go to the account transformation. You want to include the output type public key, and this is the raw public key for this Polkadot account. So copy that and put it here, and do the same for all the other ones. Okay, now that you've copied all of these in, let's just freeze this row. Okay. Now, to determine the order of these signatories, sort in alphabetical order by the raw key. Now, look here. You might say, well, S comes after M. Yeah, it does. But because all capital letters come before lowercase letters in the raw format of these accounts, this starts with the capital letters. Okay, so this is why you have to sort by raw public key. Now, remember, who are you submitting the transaction? Like, you have to remember, like, you're not listing yourself as one of the other signatories. You are listing the other signatories. So when you list these out, just omit yourself. So we're going to hide this row. 1, 2, 3. This is the order that we need to list these signatories. So that goes 2, 3, and root. That will be successful. 2, 3, root. Okay? That actually works out great. So 1, 2, 3, root. Okay? I did not plan that at all. It was just random. But whatever. It works. Okay, now that you've indicated the threshold and the other signatories listed in alphabetical order according to their raw public key, you can input the transaction that you want to submit. Do not include a time point. There is no time point because you're initiating a multisig call. And remember, our transaction is hello world. A system remark for hello world. Now, notice that it doesn't require you to like paste this in anywhere, but just something cool here. I just want to copy this part that comes after the 0x. If I control F that, you can see it's right there. It's like nested inside. It's nested inside a multisig transaction. So it is there in the multisig call data, but you don't need to like paste it anywhere because Polkadot JS makes it easier to just configure a transaction. Now, you're initiating a multisig transaction, so you don't need to include the wait. Remember, it's the executing asMulti transaction that needs to indicate the wait. Okay? Now, this will succeed. This will successfully initiate a multisig transaction provided that demo 1 has enough dot to cover the deposit. So submit transaction, okay? And this will execute perfectly. So that is how you initiate a multisig transaction. Now, once you've initiated it, notice that if you have it imported, it'll show up right here. So convenient. Look at that. View pending approvals. And the pending hash matches the hash that we saved earlier. Okay? And also, keep in mind that if you want to verify this hash, you can take the call data, decode it. So you go to developer, extrinsics, and then you go over to decode, paste the call data. You can see it's a system remark for hello world. And the hash here matches, we copy this, it matches this pending call. Paste it up here. You can see it's exactly the same. So that's how you'd verify that this call hash is associated with the transaction that is desired. Notice also that you can go to the multisig accounts page on Subscan and look, you will find it right here. You can see it's a system remark, it's in progress, and it'll bring you to a specific page for this multisig call that has the call data, the call hash, the block it was initiated in, the progress, who's initialized it, and what it's waiting for. And it even breaks it down right here, okay? So there are many ways to check on an initiated multisig transaction, and it makes it very convenient for you to manage these without using a tool. But if you want to use a tool like Multix, that's fine too. Check it out. You can import a multisig here, and I have this watched account right here. we're currently watching the demo multisig here, and this is the settings tab, right? If we go home, look at that. It's popped in right here. It's a hello world transaction. We can go to overview, and it even shows you the map here. It's very nice. You can move this around, and you could probably label these however you want. But you can see here that this multi right here, it's all listed. And all these applications do is they take on-chain data that exists and displays them in a nicer format. But it's important that you know how to do it on Polkadot JS, because these fancy applications, they don't give you an intuitive understanding of the multisig transaction. So please, I encourage you, use Polkadot JS first and then move to easier applications once you understand the intuition behind it. Finally, I just want to show you that the deposit for 20.184 dot is reserved because demo 1 initiated this transaction. Okay? So that has been reserved, and this will stay reserved until it's either canceled or executed. And that is how you initiate a multisig transaction. Now I want to show you how to cancel an initiated multisig transaction. Okay? First, I just want to show you that you can do this right here. Okay, you can cancel this call hash, and notice that Polkadot JS only gives you the option of demo 1 because it is the initiator. And remember, the initiator is the only one with the privilege to cancel. And I'll show that in a minute here. And you can do it right here, and you can reject this, and it'll work. Okay, but for the sake of the demo, I want to show you what happens, or first I want to show you how to configure it on the extrinsics tab. And then second, I want to show you what happens when someone else tries to cancel this multisig transaction. So let's say you want to cancel. You can go to multisig, cancel asMulti, okay, indicate the threshold, list the other signatories in order of their public keys. Remember, we figured that out earlier. There we go. And then it's going to ask you the time point and the index. Remember, you can find these things on Subscan, or you can even find them on Polkadot JS. You can go to chain state, multisig, and demo multisig. And you can see here, look at this, you can even find it on chain. You can chain state query the multisig itself, and it'll show you that, look, this is the account, this is the call hash, this is when it was initiated, this is the extrinsic index, here's the deposit, here's the depositor, and here are the approvals so far. So you don't even need any application to find this information. You can just use Polkadot JS. But it is convenient to use Subscan, I'll admit that. Okay. So you need the call hash in order to cancel a multisig transaction that you've initiated. So we're going to go back to extrinsics, go to multisig, cancel asMulti, indicate the threshold, indicate the other signatories in order of their public keys. You're going to want to put the call hash in, and then go back here. You can see the block, copy the block, put that in as height. That is the block height. And you can see extrinsic index. It tells you the block number -2. So we know the extrinsic index is 2, according to Subscan. Now, if I execute this transaction, this will cancel the ongoing multisig call. But let's say demo 2 doesn't like it. Let's say demo 2 is like, you know what? I don't like demo 1's transaction. I'm going to cancel it for him. Remember, demo 2 is a different signatory. So what demo 2 would have to do is omit his name in order to find the order, and it'd be 3, root, and 1. Okay? So for demo 2 to list the signatories, he would have to go demo 3, root demo, and demo 1, because that's the order of the signatories that aren't him. Indicate the threshold, okay, height, index, and call hash. Okay, so we've referenced everything correctly, and demo 2 is going to try to cancel this. Let's see what happens. Fail. Multisig not owner. So demo 2 is not the owner of this multisig call. That's why demo 2 cannot cancel it. Does that make sense? Only demo 1 can cancel it because he is the owner. He or she is the owner. So let's try it as demo 1. Okay. Demo 1 lists the signatories in order, the height, the index, and the call hash. Submit transaction. Now, since demo 1 is the owner, this will cancel successfully. Indeed it did. And you can see that the bounce unreserved, okay, multisig canceled, the deposit has been returned. We can even go here, look here, and look, he's got his dot back. Okay? And look, there's no more pending multisig call on the multisig. Look, it will even refresh subscan to see if they caught it. And indeed they did. Look at that. It's been canceled. So subscan, it took a minute, but subscan noticed that it's been canceled. How about Multix? Does Multix know? Does Multix know? Yeah, look, it no longer has a transaction pending on here. Okay? So the applications take a little bit of time to catch the cancel, but they'll catch it, and now this has been canceled. So this is no more, and no approval required. This is done. And so that's how you cancel a multisig transaction that you have initiated. Let's go over how to approve a multisig transaction after it's been initiated by one of the other signatories. This is very simple. This should go very quickly. Okay? So you see here a pending approval, and here's the pending hash. Make sure that you verify this call hash before approving it. Because remember, approval cannot be revoked. You cannot revoke your approval. So make sure that you look here. Okay, well, let me reconstruct the call data just because that's good practice. This is a hello world call. And look here, there's the call hash. So now I know for a fact that this encoded call hash is associated with this system remark. And if I agree with this transaction, I'm going to approve it. Now you can do this on the Accounts tab. Okay, so let's say you're demo 2 and you want to approve it. You cannot cancel it, right? We just went over that. So let's say you want to approve it in your demo 2. You can just hit approve and then you can approve it right here. Okay, so that's the easy way. But again, let's do it in the Extrinsics tab so you can get an intuitive understanding of what's going on here. Okay? You go to Developer, Extrinsics. You go to Multisig. And remember, you want to use approve asMulti to approve an already initiated multisig transaction unless you're the threshold approval. Since there's only one approval on this multisig, which we'll actually go back. I canceled the old remark and initiated a new one right here. So, okay, there's the call hash, call data, and okay, well you can see there's only one approval, the initiator. And we're not the threshold approval. We're not 3 out of 3. So we need to use approve asMulti. Indicate the threshold. Let's say we're doing this as demo 2. And again, demo 2 needs to list the other signatories in order of the raw public key. So that goes 3, root, and 1. So we're going to do demo 3, root, and demo 1. Timepoint, you need to include this option. If you don't, you're going to initiate a multisig call yourself. And it'll be improper because you're using approve asMulti. It'll work, it'll initiate, but it won't publish the call data on chain as it should if you're using asMulti instead. But since you're approving an already initiated multisig transaction, you want to include the time point. You can find this on Subscan or on chain using a chain query. Okay? Doesn't matter how, as long as you know it for a fact, the height and index. Here we have this block now. So copy that over. That is the block height. Now we go down and we see the extrinsic index. We see the block number -2. So we know the index for this extrinsic is 2. 2. And then make sure you get the call hash in there as well. That's right here, call hash. Paste that in. Again, don't worry about the weight. You don't need to worry about this because you're not executing the transaction. You're just approving it. And this will succeed. Indeed it did. So now let's look on the Accounts tab, go down to the Pending Approvals, and look, Polkadot JS already caught the approval. We have Demo 1 and Demo 2 have approved this call. Now let's check Subscan. Doesn't look like it caught it yet, but let's give it a minute. Now it looks like Subscan caught on, and we see 2 out of 3 approvals. It doesn't have them named for obvious reasons, but you can see it was initialized by this account and approved by this account. Okay? And that's how you approve a multisig transaction. Let's assume that other signatories have approved a multisig transaction and you haven't. And you would be the last signature, the threshold signature on the multisig transaction. Let's go over how to execute it. Again, you want to use asMulti. As I mentioned before, it's like an asMulti sandwich with approve asMulti in the middle. Since you're executing the transaction, you need to include the call data for it to execute. So let's just assume you're using the Accounts tab. The reason that I don't like using the Accounts tab is because it's kind of glitchy. So this is where you need the call data for final approval. You can go into the multisig extrinsic page to find that call data right here. And when you paste it in, if you delay, it'll like disappear. I don't know if that's like a my computer thing or if it's a bug in Polkadot JS, and then if you try to do it again, it doesn't work. So it's kind of dumb. You have to like quick draw it. So let's say you gotta like hit it quick before it like disappears. It's kind of dumb. So that's one way to do it. But again, let's just use the Extrinsics tab to see what's going on here. Again, you go to multisig, asMulti, because we're executing the multisig transaction. We're the last threshold. Let's say we're doing demo 3. You indicate the threshold of 3. You include the other signatories, which if you're demo 3, this is why you want the spreadsheet. Your demo 3, go ahead, hide yourself. And then you want to go 2, root, and 1, okay? So 2, root, and 1, okay? Then you include the time point because you're approving a multisig transaction that's already been initiated. In fact, you're executing it. And you find the block. Do not include the block number of any other approval. The multisig will be found under the block number in which it was initialized or initiated, okay? Which is right here. That's where you include in height. And then again, include the extrinsic index, which is 2. You need to know the multisig call. In this case, it's hello world. Now, it's important that you include the weight. This is complicated, but I'm going to show you how to figure this out. Okay? So let's, to save our progress, you can just copy the encoded call data for the multisig call, put it somewhere else. To figure out the weight for this call, you can go to developer, runtime calls, go down to transaction payment call API. And then you can get query call info. This is where you put the call data for the transaction that's going to be submitted. So in this case, that's right here, the system remark. Don't worry about the length. It doesn't matter, I promise. And here it is. We have ref time of this and proof size of 0. Even if we change the length to some random number, it's just going to increase the fee. Okay, so like I said, it doesn't matter to include the length. It doesn't matter. So you want to copy the ref time and the proof size, store it somewhere. And then you want to go back. I'm just going to paste it right there for now. Go back to extrinsics. Let's resume our progress by copying this and pasting it here. Okay, we're going to resume our progress. And ref time is this number that we copied. Proof size is 0. So this is the correct wait configuration for this asMulti call. So that's how you figure it out manually. But notice here, I just want to show you. We're going to save our progress again. I just want to show you that this is a correct configuration, because if I were to go and use this interface and we copy this, go here, approve, look at this. Boom. It gives the same weight. So if you're using an application, if you're using the accounts tab on Polkadot JS, it'll configure the weight for you. But all it's doing is just doing that runtime call for you and then just injecting that number right in. So you can see here, it's the same number. That's why it's important. You know, this app does that for you, but you don't see that happening. It's so important to know why it's picking that number, why it's doing that for you. There's a way to figure it out. So if all the apps in the world crash down except for Polkadot JS, you will be able to execute a multisig transaction. That's freedom. That is power. Okay? So don't be scared of that extrinsics tab. Use it. It's your powerful tool. Okay? Let's resume progress. Copy the encoded call data, paste it in. There we go. Now, everything here is correct. It is an asMulti. I got the threshold, the signatories in order, the time point of the initiated multisig call. We got the system remark in there. We got the weight. Let's execute. And this will succeed. Boom. Done. Okay? It's no longer in the multisig pending calls. It is executed. We can even see it happen right here. There it is. It's executed. And so this multisig just said, hello world, to all of Polkadot right here. Let's see if Subscan caught it. Not yet, but we'll give it a minute. Let's see now. There it is. Okay, it's executed. So this has been executed. It's done. And we did it all properly. So that's it. That's how you execute a multisig transaction. The word proxy, as defined by Merriam-Webster, is authority or power to act for another. In other words, if Alice is a proxy of Bob, that means Alice has the authority to act for Bob. Let's use a non-technical example to really understand this definition. Let's say Bob tells Alice and the local pizza joint that she has the authority to order pizzas on his behalf using his card on file. So Alice would be Bob's pizza proxy. The same goes for accounts on Polkadot. If account B tells Polkadot that account A is its proxy, then account A can submit transactions on behalf of account B. This would make account A the proxy and account B the proxied. I know these words are likely difficult for non-native English speakers. Hell, they're tough even for proficient English speakers like myself. So just try your best to follow along. In Polkadot, there are many types of permissioned proxies. However, for the purposes of this tutorial, we will only examine a proxy with all permissions over the account it is a proxy of, otherwise known as an any proxy. Furthermore, there are three kinds of proxies: normal proxies, proxied pure accounts, and time-delayed proxies. We won't worry about time-delayed proxies for this tutorial. So moving forward, let's just assume we're working with any type proxies with a time delay of 0. Normal proxies are created in the manner as I explained before in the pizza example. An account simply indicates another account to be its proxy. If an account is adding a proxy for the first time, they must place a deposit currently equal to 20.008 dot, plus an additional deposit factor of 0.33 dot. The great thing about adding the first proxy is that adding additional proxies only requires an extra 0.033 dot, since the base deposit has already been covered. Also, it's good to know that a proxy may be removed by the proxied account at any time. So if Alice becomes a pizza glutton, Bob can call the pizza joint and revoke her pizza proxy permissions. If an account removes a proxy, the deposit of 0.033 dot is freed, unless it's the last proxy on the account, in which case the base deposit of 20.008 dot is also freed. Pure proxies, or what should be called proxied pure accounts, are a bit more complicated. In fact, they are so complicated that even the Polkadot wiki itself mislabels which account is actually the proxy. Allow me to explain. If an account wants to be a proxy of a pure account, it submits a create pure transaction and places a deposit equal to 20.041 dot. This essentially asks Polkadot to generate a keyless, non-deterministic account considered pure based on the creator, known as the spawner, block number, the extrinsic index of the create pure transaction, and something called a disambiguation index, which is just a way for Polkadot to be able to know in the future which proxied account is being referenced in case multiple create pure transactions are submitted in a single batch. This method of account generation is why we call the account non-deterministic, because it is impossible to always know exactly which block and which extrinsic index your create pure transaction will be submitted in. The reason the Polkadot wiki is incorrect is because it calls the account being generated the pure proxy. However, the account being generated is actually proxied by the account submitting the create pure transaction. So the keyed account is actually the proxy because it is the proxy of the pure account that is being generated. The keyless account being generated should be referred to as the proxied pure account. So in reality, you are not creating a pure proxy by submitting a create pure transaction. You are creating a pure account, which you are a proxy of. Semantics are insane sometimes. You might ask, why is the account being generated considered pure? Good question. The reason is because it is keyless and totally inaccessible except by the proxy account, and of course .voters. Don't forget their supreme authority. In order to free the deposit that was placed to generate a proxied pure account, the proxy must submit a kill pure transaction on behalf of the proxied account. This transaction must indicate the spawner, block number, extrinsic index, and disambiguation index for Polkadot to know which proxied pure account must be killed. If submitted successfully, the spawner's deposit is freed and the proxied pure account becomes inaccessible. Please note, if a kill pure transaction is submitted while there is still dot in the proxied pure account, that dot will be totally inaccessible except through a referendum, and voters don't take too kindly to carelessness of this nature. So if you're going to submit a kill pure transaction, be sure to reap the proxied pure account of all of its dot first. Question: if an account already has a proxy, does it need to place the base deposit to add another proxy? Answer: no. Once an account has placed the base deposit for its first proxy, it only needs to place the deposit factor of 0.033 dot to add another. Question: does an account need to place another base deposit if they are creating a second proxied pure account? Answer: yes. Remember, submitting a create pure transaction generates a proxied pure account whose first proxy is the spawner. So if the same account submits a second create pure, they are generating a totally different proxied pure account whose first proxy is also the spawner. Question: can the account that spawned a proxied pure account successfully submit a kill pure transaction to remove itself as a proxy to the account it spawned? Answer: it depends. Remember, the kill pure transaction must be submitted on behalf of the proxied pure account. If the spawner does not wrap the transaction inside of a proxy transaction, the kill pure will fail. Question: can a multisig be a proxy, or can a multisig be proxied? Answer: yes, to both. If a multisig is a proxy, then that multisig has permission to submit transactions on behalf of another account. If a multisig is proxied, then some account has permission to submit transactions on behalf of that multisig. You can imagine some very interesting configurations that can arise from these possibilities. It's time for proxies. Now, I think these are cool and fun because they're simple and it's really cool what they can do. You might not, that's okay. Not everyone's a nerd like me. But let's just assume, we want to add a proxy to our account. We'll add a normal proxy first. So you can do it right here, add a proxy right here. But you know what I'm going to say. Let's use the Extrinsics tab so we can get an intuitive understanding of what's happening. So go to Extrinsics, and now we're using the proxy module. And we're adding a proxy. This is a normal proxy where demo 3 is indicating to Polkadot, hey, I want to add demo 1 as my proxy. Okay? So the delegate is demo 1. And don't worry about these other types of proxies. We're not worried about that. And again, we're not worried about a time delay. So it's an any type proxy of delay 0. And it's that simple. Look, watch. We'll just do this right now. And provided that demo 3 has enough dot to cover the deposit, that's the base deposit plus the deposit factor, then this will execute successfully. Great, and it did. Okay. Now, check it out. You can actually you can manage the proxy here by adding a new one or getting rid of this one, fine. But you can actually add the proxy to your accounts tab. So you get the Proxied account. This is the Proxied account. And this is a demo 3. And we can add that there. And now look, it's indicated as a proxied account. And we can manipulate this account from demo 1. But before we look into how to submit a proxy transaction, let's add a second proxy to see what happens. So you go to the Extrinsics tab, Proxy, Add Proxy, and we're now going to add demo 2 here. And you might say, oh, no, this won't work. You need 20 dot in order to add a proxy. But no, we've already paid the deposit base. We've already put that down, so it's covered. And to add another proxy will only require the deposit factor. Watch, this will work. We're not using a proxy call for this transaction. If Polkadot JS knows that this has a proxy, it'll ask you if you want to use a proxy for this call. We're not going to do that right now. We'll do it later. And now we're going to sign and submit here. And this will work just fine. See, look, it only required an additional deposit equal to that 0.033 dot. Dot has 10 decimals, so this would be 0.033 dot. Now we can see here this has two proxies. How do we remove it? You could do it like this. But again, let's use the Extrinsics tab to get an intuitive understanding. We're using Demo 3. We're going to go Proxy. Now we're going to remove Proxy. What's really cool is that if you have a bunch of proxies, you just want them all removed, you can just submit this remove proxies. This will get rid of all the proxies, okay? But we'll just remove one for now. And we want to remove Demo 2, okay? You need to make sure to indicate the type and delay. Again, we're just working with any type proxies with the delay of 0. And if we submit this transaction, we're not using a proxy call for this. Submit this transaction. Now you're going to see this dot come back in. And now Demo 2 is not a proxy of Demo 3 anymore. What happens when you remove the last proxy here? Let's just submit this now. Remove the last proxy for Demo 3. And look, all that dot, the base deposit has been released back to Demo 3, and now there are no proxies on Demo 3. So that's how you add and remove proxies. Let's go over how to create a Proxied pure account. This is really cool. So watch this. Let's say Demo 1 wants a Proxied pure account. So we go to Extrinsics, select Demo 1. You want to go to Proxy, and you want to submit Create Pure. We're going to indicate an any type proxy with a delay of 0. And remember that disambiguation index? That's right here. This can be any number as long as you just remember what number you use, okay? So you can use 69 if you want. That's pretty funny, so let's do it. All right, we'll submit this transaction. This will require a deposit. All right, now the proxy has been created. But now you might ask, well, how do I know what the address is for the proxy? No problem. Just go to the Explorer. You'll see the event happen. Here it is. Okay, Demo 1 created a pure, and Polkadot JS will show you right here. Let's say you miss it on the Explorer. You can just go to Subscan. You can put your account right here. You can go to the extrinsic where you created it right here. And Polkadot emits an event. Says proxy pure created. And look, here's the pure account. So now this pure is right here. What you'll want to do is add this as a proxied account in your accounts tab. So you go into add proxied, paste the pure account. You can say Demo 1 Proxied Pure. And there it is. You can see here, this is the pure, and this is the proxy. And it's an any type proxy. And that's how you create a Proxied Pure account. Now let's look at how to submit a transaction on behalf of a proxied account. We're going to use our pure account, the one that we just generated, for this example. So let's just, for the sake of it, let's just transfer 5 dot into the pure account, just to make it real. Okay? So we're just going to do this, transfer it from Demo 2, doesn't matter. There'll be 5 in there. Great. Now there's 5 dot in there. It's like, I want that dot back. I want to get that dot back into Demo 2. That was a mistake. Oh no. Well, I can't send it, using just this account because it has no key. I can't sign a transaction. So you need to submit a proxy call. Again, Polkadot JS will do this for you if you just do this, okay? Because it says use a proxy for this call. I can't turn that off because this is a pure account, okay? So you can do this just fine, you know, bounces, transfer all, fine. This will work. But again, you know what I'll say? Go to the extrinsics tab. This will give you an understanding of what's happening. Don't select your demo 1 proxied pure, okay? Let's use demo 1 to see exactly what we're doing here. We are submitting a call on behalf of our proxied pure account. So you use the proxy module, and we're using the extrinsic proxy, because the real account that we're submitting a transaction for is the proxied pure account. You can force the type. You can if you want. It doesn't matter if you do. Let's just do it for good practice. And now we want to, what's the transaction? We want to transfer all of the tokens out. Go to Bounces, transfer all. We're going to put this back into demo 2, and we're not going to keep it alive. Look, it's a proxy call. So this balance transfer here is wrapped inside of a proxy call. It's wrapped up inside. And you can see that right here. This is why using the extrinsics tab is so important. You have a proxy call, and inside that proxy call is the balance transfer. And this is the account we're submitting it on behalf of. And if we submit this, this will execute perfectly. Okay? Indeed, it worked. And if we go back here, Demo 2's got his dot back again, and the proxied pure account has no dot. So that is how you submit a transaction on behalf of a proxied account. Finally, let's see how we can kill a pure account and return the deposit back to our wallet. You can see here that this deposit is reserved. And if I were to go into extrinsics and go into the proxy module and go to remove proxy, okay, well, first off, this wouldn't work. This would have to be submitted on behalf of the proxied account. So let's say we went in here, did a proxy call, and that proxy call was to remove a proxy. And we're going to remove demo 1. Okay, I can execute this. This will work. But warning, if you do this, you're going to lose your dot. The deposit will not be freed. The only way you can free your deposit on a proxied pure account is if you kill the pure account. That is the only way it will release your deposit to you. If you remove yourself as a proxy, just in the normal fashion, that deposit's not going to be released. And guess what? You will be unable to submit proxy calls on behalf of your pure account. So you'll just lose that dot. It'll be just forever locked up. So let's start over. How do we kill a pure? You want to submit a kill pure transaction. But remember, it must be made on behalf of the pure account. On behalf of. If I watch, I'm gonna show you. This will fail. If I just try to submit a proxy kill pure using the proxy account and not the proxied account, I'll indicate the spawner. That's demo 1. This is when it was created. This is the block height was this. This is the height. The extrinsic index was, these are events. So let's look here. Let's look inside the block. Looks like the create pure was extrinsic index number 2. And remember, our funny little disambiguation index was 69. Let's see what happens. I'm going to show you this. Watch. It's going to fail. I guarantee it's going to fail. No permission. No permission, because the proxy account does not have permission to kill the proxied pure account. the proxied pure account has permission to kill itself. That is why it's so important to remember who you're submitting the transaction on behalf of. For this to work, this must be wrapped inside of a proxy call. So we're doing a proxy call. The real account that we're submitting a call for is the proxied pure account. We can force the type. Sure, why not? Just be more explicit. Who cares? And the call is kill pure. Now remember, you want to make sure that this proxy pure account has no dot in it. So to make sure, just to be 100% sure, I'm going to use a chain state query. I'm going to go to balances. Actually, it's not in the balances tab, or it's not in the balances module. It's in the system module. System account demo 1 proxied pure. It has nothing. Fat zeros everywhere. So I can kill this and I won't lose any dot. So I'm now confident that I can kill it. So let's go back. Proxy. The real one is demo 1, proxied pure. Any type proxy, we go to proxy, kill pure. Now, the spawner is demo 1. Demo 1 is what spawned the proxied account. It is an any type proxy. The index is our funny little 69 index. The block height is this here. And the extrinsic index is 2. Now this will succeed. The difference is, even though I'm submitting it from demo 1, the difference is that I've wrapped the kill pure inside of a proxy call. That's the difference here. That is why this will succeed. And you will see. There it is. It succeeded. And let's look. Proxy executed. Okay. Bounces unreserved. We got our reserve back. So that dot is now back in our account. And you can see here, look, proxied account has no owned proxies. So, in fact, this account has no proxies at all. It's killed. It's done. Totally inaccessible. Lost to the wind. And we can confirm that by a chain state query. We can copy the address, go to chain state, you go to proxies of our demo 1 proxied pure, look it up, no proxies. No proxies, no deposit, nothing. It's dead. It's gone, inaccessible. No one for the rest of time will ever be able to access this account. It is lost because we killed it. And that is how you kill a proxied pure account. It's important that bounties on Polkadot are managed by a curator account that involves a multisig and a proxy. After all, it is not wise to trust a single individual with a honeypot of funds, since they could just heist it and walk away. In this tutorial, I will cover 2 types of multisig proxy configurations, the conventional configuration and a configuration which I shall coin as the Steeber configuration. Nearly all bounties on Polkadot use the conventional configuration for the curator account. The individuals responsible for curating a bounty create a multisig whose threshold is either a simple majority or supermajority of signatories. Then they create a proxied pure account from this multisig that receives the curator role. The benefits of this configuration include the ability to switch to a different multisig without the intervention of dot voters in case anyone can no longer serve on the multisig or needs to be removed for some other reason. This is achieved by simply adding a new multisig as the proxy to the proxied pure account and removing the old multisig as a proxy. And high security, since the proxied pure account cannot have its key compromised, since it has no key, and the multisig can only be compromised if a threshold of signatory accounts are compromised. The drawbacks of this configuration are a lack of individual autonomy. The signatories on a multisig cannot remove themselves or elect a replacement for themselves without a threshold of other signatories. This makes replacing an individual on a multisig cumbersome and may lead to the complete loss of the deposit for the proxy, since there's no way to guarantee that the individual will participate in any future multisig calls. And complexity. Each bounty transaction must be wrapped in a proxy transaction, which is wrapped in an asMulti or approve asMulti transaction by each signatory. Despite the drawbacks, this has been the standard configuration for bounty curator accounts and seems to have worked quite well so far. Last November, I drafted a charter for bounty number 46 on Polkadot, the AMI bounty program. In this charter, I devised a new bounty curator configuration based on the ideal of at-will employment. This configuration is like the conventional configuration, only the opposite. That is, each signatory on the multisig is a proxied pure account of the individuals responsible for curating the bounty. So each individual generates a proxied pure account, and those accounts are made the signatories of the multisig. These are called the proxied signers. The benefits of this configuration are individual autonomy and replacement agility. Each individual may freely replace themselves without the need of a threshold of other signatories. This instantiates the ideal of at-will employment on-chain. And higher deposit conviction, since each individual is required to place a proxy deposit of 20.041 DOT to create their proxied signers, the entire curation team has a higher financial conviction to the bounty. The drawbacks of this configuration are that it must involve DOT voters to change to a new curator account in the case that enough proxied signers ghost on their responsibilities. Any individual may even kill their proxied signer, rendering their seat totally inaccessible. This is hopefully mitigated by the due diligence of DOT voters selecting the individuals who are responsible for curating the bounty funds. However, an individual may lose access to their keyed account or, God forbid, become permanently incapacitated. And complexity. This drawback is simply unavoidable, hence this tutorial. In this configuration, each bounty call must be wrapped in an asMulti or approve asMulti, which itself must be wrapped in a proxy call to each individual's proxied signer. No matter which configuration chosen, either listed here or otherwise devised, any can manage a bounty just fine. So let's dive into a demo where we combine everything we've learned so far. It is time for the grand finale, where we look at all the concepts we've learned today and combine them into understanding how Polkadot bounties are managed. So first, I'm going to start off with the conventional configuration. That is where the signatories create a multisig, and then that multisig creates a proxied pure account that receives the curator role. So first, what I've done here is I've created a multisig. I've added demo 1, 2, and 3 as the signatories and indicated a threshold of 2 of 3. I've also put in some DOT here because the multisig needs to cover the deposit for creating the pure transaction. Okay? So let's initiate a multisig transaction to create a proxied pure account. How do we do that? Go to multisig, asMulti, because we're initiating, indicate the threshold. I'm using demo 1, and I happen to know that 2 comes before 3. No time point, and the transaction is proxy create pure. It's an any type proxy with delay 0, and let's use 420 this time. Okay. And remember, you don't need to indicate the wait because you're initiating, not executing. We're going to initiate this transaction. And there we go. Now let's execute this multisig call. Keep in mind, we need the call data if we're going to use the accounts tab. We need the call data. So let's go ahead and just build that extrinsic. Again, create pure. We're using 420. And there's the call data. Let's go into here, view pending approvals, and we want to, let's just approve from demo 2, put in the call data for final approval. Oh, there's that glitch. I told you. There we go. And there we go. Polkadot JS prepares everything for you. It gets the time point, it puts in the call data, calculates the weight for you, and wraps it all into a multisig call. So great. We'll just go ahead and execute this. And this will create a pure account for the multisig. Watch, look. See, it had to place a deposit down. It had to cover that deposit. Let's catch that pure account. There it is. Okay. There's the proxy pure created for the conventional multisig. This account here, this pure account, is the account that would receive the curator role. So go in, add Proxied, put in your Proxied pure account, and you can say, we'll say conventional bounty curator. Boom. That's your conventional bounty curator. Why? Because the signatories create a multisig, and that multisig is the proxy to the pure account that receives the curator role. So when it comes down to proposing a curator, you would go to Bounties, propose curator, and let's say you had bounty number 54. You would want to propose the pure account as the curator for this bounty, and the fee would be 700. Okay, and then you'd put this into a referendum and submit that on chain. That is the conventional configuration. Now let's see how you would submit a transaction on behalf of this pure account. It's pretty complicated, so please pay attention here. Let's say you're demo 1 and you want to create a child bounty for your bounty program that you're a part of. In order to do that, you need to initiate a multisig transaction. You'd have to do asMulti. Other signatories would be demo 2 and demo 3. No time point because you're initiating. Now this is the multisig you're interacting with. So the multisig needs to make a proxy call so that it submits a transaction on behalf of the curator. Because the multisig isn't the curator. The proxied pure account of the multisig is the curator. So you do proxy call, and the real would be the conventional bounty curator, the proxy that we just made. You can force the type. Any type is fine. You can force that. And here's where you'd go, and assuming that the curator has the role, you'd go child bounties, add child bounty, parent bounty 54, value for 1,000 dot, and the LAX add campaign right there. Don't need to specify the weight. Okay. Now, obviously this will fail because there's no such thing as bounty 54, and this, even if there were, this account wouldn't be the curator. But let's just do it just to see, because it will execute. It'll just fail. Now, I almost forgot to include the threshold. Okay, this is complicated. There's a lot of steps, so don't rush it. But let's go ahead and submit this. It will fail, but it'll execute. It'll just fail. So demo 1 initiates the transaction. There it is. Now let's say demo 2 wants to execute this transaction. So what demo 2 would need to do is build the extrinsic from scratch or get it from Subscan or some other application. But you can build it from scratch. That's fine. And they would have to build the proxy call, not the add child bounties, the proxy call, because the multisig is executing a proxy call. And that call is on behalf of the proxied account to add the child bounty, because the curator has permission, not the multisig. The proxied pure account that the multisig created would have permission. So you'd build this here, force the type any, and the call would be child bounties, add child bounty for parent bounty 54, value of 1,000 dot for LAX add campaign. And there's the call data. If I did everything correctly, let's take a look. We're about to find out. Okay, let's use demo 2 to execute this call. And indeed, there it is. Okay. And, well, there's that glitch again. This is why I don't like this accounts tab. But we can rush it. There we go. All right, and that's going to execute an asMulti call. It's got the time point. It's got the proxy call. It's got the wait. It's quite a wait. And now we execute this. And this will execute fine. It won't add a child bounty because no such bounty exists. Yeah, see, bounties invalid index. But if this proxied pure account was the curator to bounty number 54, that would have created a child bounty. And that is how you interact with a conventional configuration. Last but not least, let's look at the Steeber configuration and how to interact with it under the context of a Polkadot bounty. Remember, the Steeber configuration is where the signatories create pure accounts themselves, and then you create a multisig from those pure accounts. Okay? So I'll need a minute here to create a bunch of pure accounts, but I'll record it and fast forward. So enjoy this, this little montage here. Hold, please. Okay, now we have our proxied pure account. I've generated one from demo 1, from demo 2, and from demo 3. And as you can see, all of them have the reserved dot set aside. Now, in order for these proxied signers to submit transactions, because they'll need to submit a multisig transaction, they need to be enlivened. So I'm going to quickly enliven 2 with enough dots so that one of them can initiate a multisig transaction and the other can execute it. So hold, please, once again. Okay, so now I've enlivened this proxied pure with enough to initiate a multisig, and this one with enough to, should be enough to execute the multisig. Now, let's see how we go about doing this. So we need to add the multisig first. We're going to do demo 1, 2, and 3 proxied pures. Now we'll call this Steeber Configuration Curator. Now remember, the proxied signers generate a multisig which receives the curator role. So, and here it is. All right. Now, in order to initiate a multisig transaction, I need to use demo 1 proxied pure. So we're going to go to the extrinsics and use demo 1. And we need to wrap a multisig transaction in a proxy transaction. To which account? Demo 1 proxied pure, because demo 1 is the proxy to the pure account it generated. Let's not force the type this time. It doesn't really matter. Now, this is where you do multisig asMulti. And let's say we are going to add a child bounty. Now, I just know at a glance that So this starts with 1, 4, and this starts with 1, 2. Numbers are numbers, so those will be ordered like so. So it goes 1, 2, 1, 4. That is correct ordering. And I am listing the other proxied pure accounts as the signatories, not demo 2 and demo 3. Rather, they're proxied pure accounts, because remember, my proxied pure account is a signatory on a multisig with the other proxied pure accounts. Okay? Here's where we would add a child bounty. Bounties. Add child bounty. So remember, this is a proxy call. Rather, it's a bounty call wrapped in a multisig call wrapped in a proxy call. And we're going to do bounty number 54, 1,000 dot. And this is the LAX add campaign. And since we're initiating it, it does not need to specify a wait. Okay, now that this has been configured, we can submit this transaction. And that'll initiate a proxy call on behalf of our proxied pure account, which will initiate a multisig transaction. Note here, you can see this right here. Right here. The depositor is demo1 proxied pure. We can confirm that. Look, it has reserved dot. Because this proxy pure account is the one that initiated the transaction. Now, let's go ahead and execute it with this demo2 proxy pure. So let's build it from scratch. We're going to use demo2. We are going to make a proxy call on behalf of its proxied pure account. We are going to make a multisig call. It's going to be an asMulti, a threshold of 2. Now, at a glance here, I can tell which should go first. Hang on. Okay, this is correct. First demo 3, then, ooh, I almost screwed up there. Okay, so I know that capital F goes before lowercase r. I just know that. You'll have to trust me. And that's the correct order. Now we need a time point. We need a time point, so we need to go find that. Hold, please. I'm going to go on chain. All right, we're back. I got the time point. There's the height. I got this directly on chain. And then we can do the call data here by just rebuilding the extrinsic. Remember, that's the 1,000 dot LAX add campaign. Uh-oh. We need to get the weight. We're back. Okay. Now we can take this, put it here, and take this, put it here, and we are all set to execute. From demo 2, making a proxy call to its proxied pure. That call is a multisig call. Using the other 2 proxy pure accounts, there's a time point, and that transaction is right here. So when we execute this, it will succeed, but the call itself will fail, because remember, this multisig is not the curator on Bounty 54. Bounty 54 doesn't even exist. But the multisig call will execute. Watch. And as you can see, it says bounties invalid index, but the multisig call did execute. So if the Steeber Configuration curator was the curator on a bounty with the number 54, that child bounty would have been added successfully. And notice again here that the dot is not reserved. In fact, I'm surprised. I thought the fee would come out of the demo 2 proxy pure, but the fee actually came out of demo 2. So that's interesting. But look, now this dot is no longer reserved, and yeah, that is how you would interact with a Steeber configuration curator. To conclude, let's go over what we learned today. We learned about bounties, child bounties, curators, and permissions. We learned about multisigs and how to initiate, cancel, approve, and execute multisig transactions. We learned about normal proxy accounts, proxied pure accounts, how to add and remove proxies, and how to submit transactions on behalf of a proxied account. And finally, we learned how all of these concepts come together to manage a Polkadot bounty. Thank you for taking the time to watch this tutorial. I'll see you all in the next one. Godspeed, Polkadot agents.